Hi, let's learn about frequency table. All right, so the reference to this, the reference book that I used is IBMYP3. Okay, so let's start. Opening problem. Here is the opening problem, and it says Jemima is investigating whether non-smokers are generally healthier people than those who smoke. She selected 100 smokers and 100 non-smokers, each of whom were middle-aged males. She asked each of them how many sick days they had taken from work in the last 12 months. The results were, so as you can see, these are all the results. Here are the things that we are being asked to analyze, to observe. Do you think we can clearly state the problem Jemima wants to solve? Okay, with the data she has, can we clearly state the problem she wants to solve? Alright, second question is, how has Jemima tried to make a fair comparison? Okay, why is it, how can we say that it's a fair comparison for both non-smokers and smokers? Third question is, what is the best way of organizing this data? Right now, I'll be teaching you one way to organize the data, and that's using frequency table. You'll see later how to use this way. Number 4, what are suitable methods of displaying the data? Fifth is, how can we best indicate the most typical response? Can a satisfactory conclusion be made? Right, so you can try answering this, pause, and then try to answer the following questions using the data that you have. Let's continue and let's understand some terms in statistics that will be discussed here. First is quantitative data. When we're talking about quantitative data variable, it has a numeric value and is often called a numerical variable. The information collected is called numerical data. So meaning to say it's dealing with numbers. Whenever you talk about that data, you are given the answer which are numbers. There are two types of quantitative variables. First one is the quantitative discrete variable, which takes exact number of values and is often a result of counting. Examples are number of telephone calls received each day, so it could be 0, 1, 2, 3, and so on and so forth. Your shoe size or the shoe size in your family, it could be, it's specific, there's a specific number you get. The second type of quantitative variable is the quantitative continuous variable, which takes numerical values within a certain continuous range. So when we talk about quantitative continuous variable, there is a range stated. So time taken to text a message. So we know that the time taken every time we send a message to any person it changes. So but there is a range that varies. So we could say from here it's between 10 seconds to 2 minutes, or the speed of cars on a stretch of highway. So we couldn't say that it's stable at that certain point, but it changes. But there's a range that you can be allowed to use. Alright, so again, when we have quantitative continuous variable, there is a range stated, while quantitative discrete variable, there's a specific data that you have. Alright, let's try to have some examples. Let us now organize data using frequency table. Okay, here, in the opening problem earlier, so let's look back. The opening problem about Jemima's investigation of non-smokers and smokers. Alright, whether who's healthier compared to the two, whether there's a significant difference if you are not smoking and you aren't, okay, or you are. So here it says the number of sick days is a discrete quantitative variable. Of course, let's look back at the definition. When we say discrete quantitative, okay, there is a specific answer you get. Alright, specific number answer you get. And then it says here, to organize the data, a tally frequency table could be used. Okay, so this is our main topic right now, how to construct this given a data. We can count the data systematically and use short vertical line to indicate one data value, or 4, and then there's a slash to represent 5. Alright, so I think you have experienced this before. So we will be doing some tally. Let us start. So we have written this because all the data we have are closely related. So let's check and try to tally the data. So we have here, okay, we have here 2. Alright, as you can see, all the numbers are already canceled out. That's how I tally things. Whenever I input it already, I try to cross it out so that I won't repeat it. So let's check how I did it. So every time I see the number, these are just the inclusive numbers we have. It's 0 to 8 only. So it's either they don't get sick the entire 9 months, or there's one sick day or more. Alright, up to 8. And then we have here, this is how you read this. Whenever there is like there's like lines, that's 4, but when you cross that out, this is equal to 5, as what is stated here. This ones, the horizontal line, the short horizontal lines, are actually separators. Okay, so that we know if it's, so that it's easier for us to count the frequency, the total numbers in there, the total tally. So we have here, this is 5 plus 4, so this is 9. The frequency here is actually 9. This one is 5, 10, 15, 20, 21. And then 5, 10, 15, 20, 25. Alright, next is 19. Okay. The tally is just the lines, and then there should be another one here. This is a line here, right? It's not clear. It's not slashed. Okay, let me just make that things clear. Alright, let's continue. So this should have been 1, 2, 3, 4, and then this is like 12. This is 7, and this is 4. This is 2, and then 1. As you can see, this tally, this is easy to be done, but you have to be careful when you're doing this. Most probably than not, you would, if there's so much data is going on, like here, there's a high percentage that you will repeat or not do it correctly. So the right thing that you do is to recheck your work, whether it is correctly done. You have to check and recount the numbers, whether you covered everything. Okay, so again, this is how we do the frequency table for or discrete data. Okay, organizing and displaying discrete data. What if there's another way of, there's another situation right here. What if we have a data which is grouped? So group discrete data, meaning to say our inclusive values are actually apart from each other. So that's, there's a high the range with each number is quite far, because if we will be doing the ones that we did earlier, like here, it's per number, it will give us a very long table, and that would not be a good way of showing the data. So what you need to do here is, alright, let's continue. So alright, let's continue. What if it's a group data, group discrete data? So here is the situation. In situation where there are large numbers, this is what I'm talking, of different data values, it is not sensible to organize the data in a frequency table. Alright, it is also often inappropriate to display the data by dot or column graph. Okay, so for example, a local kindergarten was concerned about the number of vehicles passing by between 8:45 a.m. and 9:45 a.m. Over 30 consecutive weekdays, they recorded the data. So here are the datas we got. In these situations like this, it is appropriate to group the data into class intervals. Right? In this case, we use class intervals of length 10. So you have to make sure that you are choosing the right interval. You have to rely on the numbers that you have and check what is the appropriate one. So we're choosing the class interval of length 10. Okay, so the tally frequency table is below. So number of cars, there is a range given, 0 to 9. And we will be tallying these numbers. So let's start and do it. So we have here 27. Okay, so 27 is under 20 to 29, 30, 30 to 39. So always make sure we start with 0. We just don't write with 1. We write with 0 because it's one of the data's appropriate going to 9. And you remember 0 to 9, that covers 10 numbers, okay, including 0. Okay, it's not just 9 numbers, but it's a class interval of 10, including 0. So let's continue 27, 30, and then 17, and then we have 13, then we have 46, 23. Alright, so I'll be pausing this, and let's continue later again. Ones that I tallied, so always tally. So we have here 0 to 9, we only have 1 data. And then 10 to 19, we have 5 data. And then 20 to 29, we have 10 datas. 30 to 39, we have 9 datas. 40 to 49, we have 4 and then 1. So after that, you also have to write the total. So we have here, our total is 1. Alright, so we have to write the data. Our data here, the total of the data. So 1 plus 5 is 6, plus 10 is 16, plus 9 is 25, plus 4 is 29, and then plus 1 is 30. Let's check whether we have the same amount of data here. So it says 30 consecutive weeks. Okay, so this is actually 30. So that's how we do frequency table. Also, if you want to find the mode, median, and mean or range, you can actually do that here. So this one. If you want to go back and check it, this is easier to find the mode. The most repetitive number is 2. Okay, it has 25 datas. What is the mean? What you do is you have to add everything. Okay, you multiply it first. So you have to 0 times time next like the data. You have to multiply first the number here going to the frequency, and then add everything and divide it by the total number. And then we have mode, median. Median is to check what is in the middle of everything here. Range is we subtract the lowest to the greatest. So like here, the greatest to the lowest, to 8 minus 0, the range is 8. So like that. So you can actually find the measures of central tendency from here, or the mode, median, and then range. So that's all for frequency table.